right, so this will be the third and final review session of the content of the AP Computer Science curriculum. This is the third of the 3 periods, and it will cover the following. Let's take a look. So there are 15 topics over 3 units. The 3 units are the arrays unit, the array list unit, and the 4 units, the 2D array unit, and the recursion unit. All right, let's get the pen ready. I do not want to use the pen. I'm going to use my finger. That ended up working a lot better yesterday. Okay, so recursion, 2D arrays, array list, and arrays. This will be 15 topics at about 4 minutes per topic. This shouldn't be too bad for today because I previewed these topics. But let's dive into each of these topics, starting with topic 1, arrays. Okay, this was something we covered in extensive detail in the 30S computer science course in the unit called arrays. So you can see here the 8 points. What an array is, that an array is a collection of data, okay, a one-dimensional object that is indexed, has a length that's always one less than the index. Oops, pardon me. Sorry, the last index value is one less than the length. That's what I meant to say. Okay. The use of array objects allows for multiple items to be represented by a single name. It says a single variable, but the name of the array allows you to access all the elements by then using the index number. So each element does not have a different name. It has a different index number. That's essentially what that point means. The size is established at the moment of creation and cannot be changed. That's not quite true. You can change the size of an array, but it ends up wiping out the contents, so I get their point, right? This is why arrays are sometimes called static data structures, because they do not change in size, even though the word static in coding means shared. A static data structure in this context means that this data structure, this array, does not change. The size or the length of it, when you create it, and that's what it is, okay? Arrays can store primitive data types or object references. That just means you can have an array of class level objects, but each is a link to a memory address, right? That's the way you could look at it if it's an array of classes. So each thing is linked to whatever the, like say you made class person, each spot in the array would link to that person object. Okay. So that's what it says there. Okay. Arrays are created using the keyword new. Okay. And then it says, depending on what type of variable it is, what type of array, pardon me. Okay. In Java, arrays are auto-initialized. This means, because you'll see that word in computer science, initialized, means what's its initial set values. So if it's type integer, a primitive data type like integer, it initializes every element to 0 inside the array, right? Now that does not mean the index number. The index numbers are already set to index or to locate spots within the array. But if the type is integer, it pre-initializes it to 0. If it's type double, it pre-initializes it to 0.0. I bring that up because I didn't really go into that in detail in when I taught you guys array, because I actually think that's a bad way to think of arrays. Just because they're auto-initialized in Java doesn't mean every programming language does that, and that's actually a really good point, I think. If you essentially think when you create an array, it's just empty, it's not preset to values, you can translate that to other programming languages where that doesn't occur, where auto-initialization doesn't occur, because then you don't know what's in the array. But in Java, everything with a double is initialized to 0.0. Everything with a Boolean is initialized to false throughout the array. That's what it essentially says here. Int are initialized to 0, double initialized to 0.0, and Boolean is initialized to false. It doesn't mention the char type specifically, but then it goes to say, well, what if it is a bunch of objects from a class. What if this is not an array of primitive data types? This is like, for example, strings, and an array of strings. What is each spot initialized to? And the answer is null values. Everything is initialized to null, okay? So you could potentially get a null error if you try to access an array element of a class level object without having preset it, okay? So that's why I like that. That's kind of more along the lines of the way primitive arrays are used in other languages.
I'm guessing if you also have a array of integers, like the integer class, it would all set to null.
That's right. Yeah. You mean the wrapper class
The wrapper
integer?
class,
Yeah. Absolutely. Okay. Then it goes on to mention a weird terminology, not that weird, but one I haven't really used, which is this idea of an initializer list. Okay, that's when you do one of these things. When you go like int array equals, and then you do the curly brackets. That's what you would call an initializer list or an initializer array. I don't use that term because it's not commonly used, but that is what it means by that, is where you're used to create and initialize the array at the same time. So that's your clue right there. That's what it's saying. You're creating or declaring the array and initializing its values all at once. Okay? Square brackets are used. You knew that. The valid index for array are 0 up to the length of the array minus 1. And again, you knew that as well. That's what it says there. And then if you try to go beyond the bounds of an array, you're going to get an out of bounds, array out of bounds error. Again, you knew that. All right, let's move on to topic 2. Traveling these arrays, or traversing the array. You know this very well as well. The basic way you traverse an array is with a loop, okay, which goes from 0 up to the length minus 1. Now it mentions that you can do this with a while loop. You certainly can do this with a while loop. So while, and you somehow create a condition that does that. But more commonly, the for loop is used with arrays, because the for loop uses the variable I, which initially starts at 0. The for loop variable often says less than the array dot length. And the for loop variable, as you know, was often up by 1. So the for loop works really well with arrays, okay? That's what it's saying here. Traveling or traversing an array with an indexed for loop, that's what essentially is there, or a while loop. Access the elements using their index. So that's how you access the array element, using the variable that's in the loop. Since the indices for an array start at 0, right, and end at the number of elements minus 1. Okay. Here, although I'm saying dot length, I'm also using less than. That works the same as minus 1. One-off errors are common with arrays. That's what it's saying. That's usually where you exceed the end of the array. That's all it's saying there with that. And again, you get that type of error. All right, the enhanced for loop with arrays. So you did learn about the enhanced for loop in the 40S course, okay? The enhanced for loop is mentioned in the AP curriculum. I don't know how many exam questions have used it, but it could be there, right? There could be there. The enhanced for loop, what would be the structure of that, right? So it's a for loop, okay? Still gonna be a for loop, but there's some things that are a little different about it, right? It includes a variable, right? So the for loop with an enhanced for loop depends on what the array is, right? So let's say I had an integer wrapper class array built. Let's say it was filled with values, okay? So now in the enhanced for loop, okay, it's going to say that it's going to create a variable for the enhanced for loop, and it will automatically transition it to the next element. You don't have to write the plus plus statement, okay? For each iteration, that variable is assigned a copy of that element, right? Now, by the way, without looking at your notes, how would this for loop internal part go? What would it say for an enhanced for loop? It's not going to say int I equals 0, bracket, or semicolon. What's it going to say in the enhanced for loop?
Integer.
Integer, yeah, that's the data type.
And then your variable type. Or
and then a name for it, right? So let's just call it index,
And then your colon.
and then a colon,
And then the array, or the data type.
and then the name of the array, A. And the way I taught it to you guys is you should read it as for every index in the array, right? It will loop automatically. So now you could say output index. And it would automatically transition index through the entire array. It'll automatically know when to stop. It does all of that. And you can see that there. What it can't do in enhanced for loop is change the array. You couldn't say index equals 7 and expect the array to change to a bunch of 7s, okay? Here it says it does not change the value stored in the array. Personally, I'm not a big fan of the enhanced for loop. It is a feature you can use, but it has limitations. There isn't a lot of benefits to using enhanced for loop. Some early programmers think it reads nicer than the standard for loop. I don't know if I could accept that argument, but it's covered in the AP curriculum, so you should at least be aware of the enhanced for loop. That it could show up in exam questions. It seems like you guys give me a sort of every once in a while it shows up, okay? It also makes the point that you can rewrite an enhanced for loop as a standard for loop. All right, moving on. Algorithms using arrays. So all this is basically saying is it's warning you that you should expect for loops and arrays to show up in exam questions. As you know, they will, right? It's actually very common in AP exams to see the for loop showing up and to see the array showing up, okay? So it says, here's things you could expect. Okay, standard algorithms that you could modify and that you could create, essentially in long or free response questions. Standard algorithms, too, determine the minimum in an array or the maximum in an array, okay? To compute a sum or an average or a mode, okay? Determine if an element in the array meets a certain criteria. So if it meets a certain criteria in the array, it does something, right? Determine if at least one element has a particular property. Do all the elements if all of them meet a certain criteria, okay? Access consecutive pairs of elements. I'm not even really sure what it means by that. Access consecutive pairs. Determine the presence or absence of duplicates. That could be a nice piece of algorithm you have to write where is there any duplicates in this array kind of thing, okay? There's also, it mentions algorithms to shift the elements in an array, left or right. Okay, and reverse an array. So my advice to you guys is this might be a good way to study, is write code that can do these things. To create a basic array and say, can I find the minimum in the array? Can I find the maximum in the array? You can even make them into methods. A method called findmin, findmax. Calculate sum, calculate average, calculate mode, okay? Check to see if a certain element is in an array. That's a standard searching algorithm, right? Kind of thing. Check to see if they all meet a certain criteria or not. That could be a return Boolean algorithm. Is everything in here a 5 or not, right? Check to see if there's duplicates. Shift the elements in reverse. These would be great examples of that. Kim. What's mode?
Most amount of similar numbers in it. That's not
a
a
list. It's whatever number appears the most. So it's
here.
like 1, 1, 2.
It's
what would
which
be one?
value appears the most in the list, right? So if you have a deck of cards and you just pull out 7 random cards out of the deck and there's 4 4s in there, you'd say 4 is the mode, right? There's more 4s in this collection of cards than anything else, right? That's what mode means, right? They didn't like mode. Mean is average, mode is that, which occurs the most. Okay, good question. All right, next point, topic 5. This is the introduction of the array list to the curriculum. Now, we spent a period going over array list values, but the array list is in the Java curriculum for AP, it's talking about the one that you can import, okay? Not one you create yourself. In our 40S course, we created the linked list. The array list is a version of the linked list, okay? Or pardon me, I guess it's the other way around. The array list is a version of a linked list. The linked list is the bigger concept. The array list essentially is that. It doesn't necessarily have all the features that we wrote into our linked list, okay? And you don't need to know all the features of this imported list. It gives you the methods that you need to know. So for example, you can build a linked list through a constructor, okay? Construct the linked list. Now, let's be clear about what it is. The array list, as different than the array, is a dynamic data structure. And the simple way to define that is it can grow and shrink as the program's running. Whereas the array list sets a size and it doesn't change that size. So the dynamic structure, as you can see, it's mutable, meaning it can be changed, and contains references to objects. So I'm not sure why they put that, but the array list can store data of any type.
Just making sure the enhanced for loop also works on this array.
It does, yes it does, yeah. Because it's an imported device, the enhanced for loop can work with the array list. The linked list that we wrote, the enhanced for loop couldn't work with it, just because we hadn't written that code. We could write our code in there to make it work with that, but we didn't do that. We already did plenty with the linked list we wrote. But the array list that you import has a feature where you can use the enhanced for loop on it. It uses generic data. This is something we also studied in the 40S course. The AP curriculum doesn't go over generics like we did. It just mentions it like right here in the curriculum and a little bit over here, but it never really defines it. That to me is a bit of a flaw in the AP curriculum. It doesn't really explain to students what generic data is. You know what it should be. Generic data means it can be anything. So it's using that placeholder E. We use the placeholder T when we did ours, but it essentially means it can be substituted with anything. Generic data is usually placed within those less than, greater than, or the angle brackets, okay? And it specifies the type, okay? And that's what it's talked about in these last 2 points, is when you create an array list, maybe we'll do that real quick. You use the angle brackets, okay, along with the constructor. And those angle brackets can go in 2 places, here and here. And inside those angle brackets, you put the data type, okay? So one of these can be left open, right? Call that the diamond. It's a weird word. We had a big deal about that, okay? But that, but the one you leave open is usually the one over there, right? I think it has to be that one over there. It even mentions that using the angle brackets during construction is preferred because it allows you to find potential errors. It at least knows the data type going in, right? Because you can make an array list without the angle brackets, and it will allow that to take place. But then it doesn't know the data type until you start using the type. And so it's got potential errors there. All right, moving on. Topic 6. Methods built into the array list. We spent a lot of time doing this, but there are a list of them here. It says it's part of the Java util, which means you are importing it from util. And there's things, as it mentions here, like the size method. Let's try that again. The add method. Okay, you can see there the size method, the add method. Another version of the add method, so it overloads the add method. The get method, the set method, so accessors and mutators, and yeah, that's about it, I think. It does have a specific list of these that you will get on the exam. The exam will give you this in the reference sheet. which is right in the Blue Book app, as we mentioned yesterday. Right in the Blue Book app is that reference sheet on what is available in the array list in terms of methods. There are more than those methods, for sure. Now, if you look at these methods here as well, one of the reasons why when I taught you guys the linked list, we went into way more detail, isn't just to learn these methods exist, but to actually get under the hood and learn how they work. So if you look back at our 40S linked list code, you'll actually see that we didn't just call these methods, we wrote these methods, which is way beyond what they expect from you at the AP level. And that was, I hope, to give you guys that deeper understanding of what size is essentially meaning, what get and set are really doing, what add and the version of, we overloaded the add method in our linked list as well, to really give a feel for kind of what the referencing going on. You guys might remember we had nodes, we were looping and all that stuff. No, you don't need to know that stuff for the AP curriculum. You just need to know how to use these methods in the context of an imported array list. Okay, topic 7, we're halfway. For array lists, sorry, is there a question?
No.
Traversing using a for or while loop, okay? And traversing using the enhanced for loop. That would be basically very similar to the way it works in arrays, although you'd be using get and set methods if you're changing or accessing the array. Looping or iteration statements can access all the elements in the array list, called traversing. Deleting elements is a little trickier. Deleting elements of an array list is easy if you're deleting one item at a time, but if you're deleting in a loop, that's problematic. Because watch this, say I had an array list and I ran my for loop. So the array list. Okay. And let's pretend this method exists. Delete spot I of the array list. What's the problem with that? Well, it's just looping through the array, deleting each spot. The problem is here. Because as you delete it, then the size changes, right? And that could be potentially problematic. So that's what it says here. Deleting elements during a traversal of an array list requires special techniques to avoid skipping elements or to avoid a size problem. And it says the indices start at 0 and end at the number of elements -1. Accessing an index value outside of this range will result of an out of bounds exception. That makes sense. Changing the size of an array list while traversing it, which is what this would do, it would change it, or maybe even adding something to the array list, that would also change the size of it, okay, would then result in potentially some kind of error taking place. So what they're basically warning you is if you're going to loop through an array list and make a change to the array list inside that loop, it could affect things with the loop because it's so dynamic. That's all this whole point is about, okay? All right, topic 8, developing algorithms for array lists. So it's basically saying the stuff you did with arrays, the sum and the average and all that, you can do that with array lists as well, okay? To insert elements, to delete elements, the same standard algorithms used with arrays. This could require strings, okay, to be traversed. So it's basically just saying you can expect questions, the same kind of questions you get with arrays, you could potentially get with array lists, okay? So that difference between the array versus the array list kind of question would be something that you could potentially have an exam question on. What's the benefits of array? What's the positives of arrays? What's the positives of the array list? What's the negatives of the array? What's the negatives of the array list? That might also be a study technique you could do, is to fill out a chart like that. What's so good about arrays? What's bad about arrays? What's good about array lists? What's bad about array lists? And often the same thing might appear on both sides, right? What's good about an array might be bad about the array list and vice versa. So it's just kind of gets your head around the differences there. All right, topic 9, searching. So this is such a weird one because the AP is so vague about searching and sorting, okay? They mention some algorithms by name, but they don't explicitly say that students need to study them. We did put a little time into this to help kind of clarify this a little bit, but unfortunately I don't have a really good answer for you is exactly what could show up in your AP exam. In all the AP exams I've ever studied, at no point did I see a question that said something like, write a binary search algorithm. Did I ever see a question that said, write an insertion sort algorithm? Even though those things might be mentioned in the curriculum, it's unclear exactly what they want. So let's look specifically. Apply the linear or the sequential search. Apply it, not necessarily write it, to search for specific information in an array or array list. If we go back to what we just talked about with arrays and array list, it also mentioned that you might have to look for the occurrence of an item, essentially applying that linear. Linear just means you go in line, right? So if it's an array or an array list, you just go, is this the thing I'm looking for? Is this the thing I'm looking for? Yes, this is the thing I'm looking for, right? Start at the beginning, go through it sequentially. That's the search it's talking about. There are standard algorithms for searching. That would just mean something like a for loop until you find it with an if statement inside. Search algorithms check each element in order until the desired item is found, or if it goes past the end, then we know we didn't find it. That's the basic search algorithm. It's when we get to this slide on sorting that it gets even more confusion, because two sort algorithms are specifically mentioned. The selection sort and the insertion sort. And it boggles me to this day why they picked these two. I can get this one. Why they picked this one, insertion, boggles my mind. To me, and I can just point to a poster I have up on my wall that I ordered just from a company on sorting algorithms up there. The first one it mentions is the bubble sort, which is always the first sorting algorithm I generally teach. Yet the AP curriculum ignores that sorting algorithm. So to prep for this, rather than just right here on the board today, I took a second to create a very simple version of these two algorithms, which I'm going to screen capture for you guys right now. Pop right into our slide here. Let's make it a lot smaller. Now again, it does not state you need to have these memorized or anything like that. But why not? Let's just see if you guys could recognize at least a little bit about what's going on with these two sorting algorithms. The selection sort and the insertion sort. Okay, we'll start with selection. Don't look at the code. Read my comment. This is me reducing the selection sort to a one-sentence description. It repeatedly finds the smallest element from the unsorted portion of a list and swaps it with the first unsorted element. Okay? So with that in mind, without even necessarily looking at the code, let's essentially draw what that means. So to find the smallest elements, okay? So we have an array, 4, 7, 2, 6. Okay? So it says it repeatedly looks for the lowest. Is this the lowest? No. 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 Yes. That's the lowest. Swap it, it says, with the first element that's unsorted. So the 2 gets swapped with the 4. The 7 and the 6 remain in spot. And then it will keep doing this. Now the 2 has now been locked in at its lowest spot. Is this the lowest? This is the lowest. Swap it with the 7. Okay, now this one's locked in. Let's keep going. This is the lowest. Swap it with the 7. This one's locked in, and then eventually it gets to the end, and we have 2, 4, 6, 7. It is now in order. Okay, so that's essentially how that algorithm works. And right here you can see a basic implementation of it using a for loop with a nested for loop. Okay, so it has a for loop with a nested for loop with an if statement inside of that and a swap algorithm down here. Okay, the selection sort has that property. The insertion sort algorithm, in a one sentence description of what is an insertion sort algorithm, it builds a sorted list by inserting each item into its correct position. So this one finds a number and then inserts it into its position, is essentially how it's saying. It builds the final by one element at a time by inserting each element into its correct position. You can kind of see down here that it's using a for loop with a nested while loop inside, okay? But essentially, in a very similar way, okay, it would essentially put the 2 into position, then put the 3 into position. The 4 would already be in position. And then put the 6 into position. And then put the 7 into position. So it would go through and go, okay, put the 2 into its position, go through, now put the 3 into its position, right? It's positioning the elements that way. That's a way you can think of the way the insertion sort algorithm works. But again, it boggles my mind why the AP is so unclear about actually a fairly complex topic in computer science. But here's again what the curriculum actually says. Apply these algorithms to sort elements of array. Not write them, apply them. Selection sort and insertion sort are iterative, meaning they have loops that can be used to sort elements. Compute statement execution counts an informal runtime comparison of sorting algorithms. What it means by that, does it mean using something that I've mentioned to you guys before, the big O notation, to actually calculate? I don't know. But basically, if this has a for loop with a nested for loop, okay? And let's say you had 10 items in your list. Well, you know that this loop would run 10 times, and the nested for loop could run 10 times. Well, 10 times 10 is about 100 loop iterations, okay? In big O notation, this would be n squared, right? N squared of order based on the number of elements in that list. This one is also n squared. Although it has a for loop with a while loop, that while loop is essentially acting like a for loop here. It just has 2 looping conditions. That j is greater than 0, and that the element is greater than the key, right? It'll keep moving it along in that way. But it essentially is, again, you look at worst case scenarios for these types of algorithms, we're talking about n squared complexity, which means if we have 100 items, it's going to need 100 squared time units to complete, okay? Whereas the linear search, if you think of a linear search, it's order n. Because if you have 100 items, you just need to make 100 checks through the entire array. But a sort takes more time. And in this case, it's taking n squared amount of time. The bubble sort, which I mentioned there, is also n squared time complexity, right? There are sorts that are faster than those, but they are a little different, right? That is something you'll learn in the future. Anyways, that's what it's essentially saying there. I don't really know what it means in that context. I hope through what you've examined and all the types of AP questions you've encountered, that you haven't seen something that I haven't covered with you guys at some level. Okay, and if you have, please let me know so I can dedicate more time to specifically targeting that learning outcome for you. Then weirdly, in the middle of the array list unit, the AP gives you ethical issues around data collection. I don't know why that's in there, but it's in there. Now that is something, no, I haven't formally taught you, but we have informally talked about risks to privacy. Watch your data, kids. Collecting and storing personal data. Watch out for that, kids. When using the computer, personal privacy is at risk. Programmers should attempt to safeguard your personal privacy, and computer use in the creation of programs have an impact on security which can be beneficial or harmful. All right, here's my theory why this is in there, okay? And again, this is just a theory. AP exams grade on a curve. This is common at post-secondary university level grading as well. I've explained to you guys what that is before, that there's a standard bell curve generally for exams where high value marks, like 100% on an exam, and low value marks, like a fail of an exam, are within the curve. And then this would be kind of where you'd have the highest number of students. So the highest number of students who perform on an exam generally falls somewhere between getting 100% and failing. Now, where that actual curve value falls, well, it depends on the course, right? Some courses will have a higher curve value, right? Because they are quote unquote easier courses. Whereas some courses, like say a physics or calculus course, that curve is gonna shift, right? Not this way, but this way, right? So you're gonna have more students failing and even less and less students getting those really high marks, right? What they want is to see that distribution curve. They don't want to see it not occur. The last thing an AP exam would want to see is just like this, right? Everyone did great, and there's just a couple people didn't do well, right? Most people in this exam went here, or the reverse of that, right? Where everybody failed and nobody got 100%. Nobody got 100%. They want to see a standard distribution curve. And then honestly, they're going to create questions to create that curve. What that generally means is they're going to put in a couple very difficult questions to distribute the curve and a couple easier questions to distribute the curve. I would say this is for easier questions. That they're going to throw you a bone maybe with a question about, hey, is it a good idea to insert all your personal data on a website you've never been on before? Yes or no? And you're going to be like, well, no. And you're like, why is this question so easy? It could be because that question was in there specifically to help build the curve. That's my theory. I don't know, maybe I'm a conspiracy theorist, but that to me is what's going on with this curriculum point here. All right. 2D arrays was its own unit in the AP curriculum. We studied this in the 30S course. 2D arrays, also known by its cool name, the matrix, okay, is a collection of primitive or object references. So it's basically like an array, but now it has 2 dimensions to it. So if this is your standard array, right here, a 2-dimensional array is an array where every element is in itself another array, creating the matrix effect, right? An array of arrays, okay? It even says that. 2D arrays are stored as arrays of arrays. Therefore, 2Ds have created an index similar to 1D arrays. The similar does say, and this was something I did just noticed as well. In the curriculum it says, for the purposes of the exam, when talking about an array with 2 dimensions, a first dimension and a second dimension, the first index is used for rows, and the second index is going to be used for columns. So if you see a 2D array question, assume it goes rows, columns, rows, columns. That's what they're saying to you right there. Assume that if it's not already explicitly written in the question. I hope they do write it in the question for you guys, make it clear. But if they don't, if you have a question that you're not sure about and it's using 2D arrays, it's going to be rows, columns. The first dimension is rows, the second dimension is columns. That will affect your for loops if you have to write for loops. Your first for loop will go through the rows, and then your second for loop will go through the columns. That's essentially what this is all saying there. All right. Traveling 2D arrays. I guess that's the same thing, right? Talks about the idea of nested for loops, or even nested enhanced for loops. I don't know if I've ever written a nested enhanced for loop matrix traversal, but I guess it's possible. And that's essentially what it says. The outer for loop is used to travel the rows, and then the inner for loop is used to travel the traverses a single row, which means it's a single row is all the columns of that row. Let me just quickly just lay that out for you guys to maybe try and make that a little more clear. So if I have a for loop, R equals 0, R is less than A dot length, R plus plus. Then the inner for loop, C equals 0, C is less than A R dot length, C plus plus. Okay, the array, row, column. Okay, so that's what it's talking about, okay? The outer loop, R, goes from 0 to the length of the array. So let's say this is a way to visualize the matrix. So it's going to go through the rows right here, starting at 0. So the length of this is length 5, and then we can visualize the columns. Okay? At length 4. Now this is just a visualization, right? So the visualization, it's essentially the first dimension is the length of the first dimension of the array. So this would have been created like this, int A, bracket, bracket, equals new int, bracket, bracket. This first dimension is what the length of that dimension would be, A dot length. So if we visualize that as 5, this is the number of rows. So this is 5 rows, okay? Now if I drew it the other way, we would just visualize that as the rows. And then this dimension, the second dimension, is this dimension, or how long each array within the array is. That's maybe another way you can think of that. That's why I went A bracket R. The length of that array within the row. In that case, it would be 4 right here for the columns. Okay? It is a bizarre way, again, to kind of visualize it. It's just one of those ones that I think can throw you off a little bit if you don't practice the two-dimensional array type questions.
So what if you wanted to traverse the columns before the rows? So
Well, you'd have to write the logic to kind of do that, right? So you're saying I want to go down like this?
Yeah, you want to go down like that.
Yeah, so you could flip the for loops for sure, but then you just got to be sure you get your indexing correct, right? Like which index is going correctly, right? So it's really important to kind of visualize what's going on there. Okay. The last 2 points, we're on 14 and 15, is about recursion, okay? Recursion is a topic. We studied recursion in the 40S course. The thing about recursion is generally you either get it or you don't, okay? The basics of recursion is we're talking about a method. Recursion is a method, okay? That's the first thing you know about recursion. Recursion is talking about methods, okay? So when we're talking about methods, we're talking about calling methods, we're talking about parameters, we're talking about returning, etc. Okay? All right, here's what you need to know about recursion. Recursion needs 2 specific cases for it to occur. 2 cases within the method. 1, it needs what's called a base case. 2, it needs the recursive case. Okay, let's get into that. Recursive case, this is the key to recursion, is where the method calls itself. This is where a method makes a call out to the method itself. That's a recursive case. A base case is what essentially stops recursion from taking place. If you don't have a base case, the method will just keep calling itself forever, creating like an infinite loop type of scenario. All right, let's see what the AP says. Determine the result of executing recursive methods. A recursive method is a method that calls itself. There it is. Recursive methods contain at least one base case, which halts the recursion or stops the recursion, and at least one recursive call or recursive case where it calls itself. Then it just goes on to say that each call has its own set of variables, including the arguments. They call it formal parameters. Parameter values capture the progress. So that's where you do that, much like a loop. Any recursive solution can be replicated through use of an iterative. This means you could rewrite it as a loop approach if you wanted to traverse strings, arrays, or array list objects. We'll write a quick recursive method here real quick at the end, but in the last topic about recursion is that you can also apply that to searching and sorting. I will finish the the video after school as usual for you guys. Have a good day, and we'll see you tomorrow. All right, let's finish this video up. All right, so the final point of this review is under Unit 10 recursion, and specifically what we're looking at here is the concept of recursive search algorithms. So maybe we'll do a quick example of something like that, just really simply, and just take a look at how this could work on something like a string or an array or an array list, right? And then again, this strange piece of the AP curriculum where it says the binary search here. Does it say you write a binary search? It just explains what a binary search in the curriculum. In order to use a binary search, you have to use it on a sorted list. Okay, and then it talks about how it works, starting at a sorted list. So again, this could be very simply just like this. Right? We have a few more. Okay, so if I'm searching for the number 6 in this list, it starts in the middle, goes, is that the 6? No. Okay, then it does not need to look on this whole half because 6 is greater than the number I'm currently at. So now I can just look on this side of the list for the number 6. And again, I'll start in, say, the middle here. So let's say I start at 8. Let's say that's the calculated middle. Is that the 6? No. But now we know that 8 is, that 6 is less than 8. Whoops, that's not written correctly. 6 is less than 8. So now I can go into this section, right, and look. And then eventually I will find it. So the binary search is a very efficient searching algorithm because it keeps working on half of the list at a time. And so are you supposed to write this? The AP curriculum is not clear. It just explains that you start at the middle of a sorted array or array list, eliminate half the array each time until it's either found or all elements have been eliminated. Binary search is more efficient than the linear search. It tells you that as well. It can be written either iteratively in a loop or recursively. That would be certainly a challenge to do, but the AP curriculum doesn't say students should be able to write that. And then again, apply these algorithms to sort elements. And then it even mentions at the end here a third sorting algorithm, the merge sort, which is an even more complicated sorting algorithm, right? So a strange way for the AP curriculum to kind of put this content, just sort of slip it in to the AP curriculum. But why don't we, just as we wrap up, just do a quick example of something it kind of talks about here, which is a recursive search algorithm. So say we had a method like this. Public int search, okay, through a array for an item. Let's call the item I. So search A for I. So the normal way this would be done is with a for loop. For, and I can't use I, so x equals 0, x is less than a dot length, a plus plus, if the array at spot x equals I, return x, otherwise return something like -1 that it didn't find it. That would be a basic search algorithm with a loop, okay? If we were doing this recursively, we're gonna add another parameter to this. So we're gonna look for item X, and I'm gonna keep track of what index number I'm at, okay? So now I can write my base case. If the array at spot I equals the value X I'm looking for, return I, that's the spot I found it at. Otherwise, return search the array for X, and now go to the next item. So I'm going to recursively call the method, move up one there. Now I would need a second base case, because otherwise I will go out of bounds if it's not in the array. So I would also maybe have the if statement, if I is greater than a dot length minus 1, return minus 1. So I have that base case there. Now I don't need a loop then to do this. This would be a recursive search algorithm where the method search calls itself using a recursive case. And that, kids, is going to be the end of this review and the end of the review in general.